present our speaker this evening. Lisa Floyd-Hanna is a professor of environmental studies at Prescott College and research associate and curator of plants at the Natural History Institute. Her research primarily concerns fire in pinyon juniper woodlands on the Colorado Plateau and historical reconstruction of fire in the Prescott Forest. So, Lisa Floyd-Hanna.
What I'd like to do tonight is talk about our area and the uniqueness of our area. And one of the unique things about the area is the vegetation, of course, but the fire that drives that vegetation. So I'm going to talk about historical reconstruction and fire patterns, but before that, I would like to introduce, there we go, the area called the Mogollon Highlands. So what I wanted to do tonight is, first of all, talk a little bit about the natural history, and particularly the natural history of the transitional ponderosa pine areas, forests of the Mogollon Highlands, and then go into some research that I'm doing with the Ecological Restoration Institute at NAU on the ponderosa pine forests, and then end up by talking about a couple of wildfires that have happened here and the kinds of trends that we're seeing over time. So I will try to keep this to 45 minutes, I believe, is the limit, and maybe we'll have some time for questions as well. Okay, first of all, Mogollon Highlands. The Natural History Institute has had an initiative for the last few years where we have been recognizing the uniqueness of our area, particularly between 3,500 and about 7,000 foot elevations from central Arizona into New Mexico, where floristically and functionally things are different. And we have been focusing on this area which has been called a neglected center of biodiversity, hence our interest, a biodiversity hotspot, as well as a notable center of endemism by geographers and botanists in the past, but it's been surprisingly overlooked by the scientific community. One of the reasons why this area is so biologically diverse is because it is a crossroads for species coming in from the north, species coming in from the south, from Mexico and southern Arizona, and even the east and the west, creating a very diverse area of very rich biodiversity and, in fact, a notable crossroads. And I wanted to give you a couple of examples of that and then show you how we're defining this biodiversity at the Natural History Institute. For example, we have 4 species of junipers that overlap in our area. One of them is, of course, the alligator juniper. And alligator juniper comes in from the south, from Mexico, and makes its way into our area and kind of stops there. These data are from SciNet. SciNet is a very wonderful database of plant locations throughout the south. It links all the herbaria in the area and is really a wonderful resource. It also has a couple of funny little spots like that probably isn't right. But taking the data at face value, we are using SciNet. So alligator juniper then from the south overlaps with Utah juniper, which comes in from the north and finds its southern distribution in the Mogollon Highlands. Similarly, Rocky Mountain juniper comes in to our area and not much further south. I suspect those points as well. And one-seeded juniper comes in from the east and overlaps with these species. So we have this convergence, this is just one example, of 4 species of junipers giving us a very rich flora in that area. So what we're doing with these distributions is a GIS little trick called a directional distribution ellipse process. And what we do is we take the distributions, and the GIS looks at those distributions and the angle, for example, this angle where most of the plants run, east-west, or essentially north-south, and one standard deviation of their distribution. In other words, each of these ellipses encompasses the area that 2/3 of the plants are found, one standard deviation. And so what we do is put these on each other and see where they overlap. So in our case, we know that these 4 species all occur in this area, but their ellipses, 3 out of the 4 ellipses overlap in what we're calling the Mogollon Highlands. And we have done this kind of analysis, I'll show you several examples, for many plants, for several birds, for reptiles, for snakes. And what we're trying to do is refine the area, the Mogollon Highlands area, oh, I guess I jumped the gun on that, using these ellipses. So let me give you a couple more examples of distributions. So here we have 2 species of manzanilla overlapping. We have a very important plant, the bright silk tassel, coming in from the south, from the Sierra Madre Occidental. So this is an example of what we call our Madrean shrubs. They came from Mexico, from that area, post-Holocene, and made their way into the Mogollon Highlands. This is a very important species, of course, for us. Jojoba, similarly, mostly south, makes its way north, and again stops basically in our area. And then there's other species that come in from the east, like Rus ovata, and it's western, or its eastern, comes in from the west, excuse me, and its eastern distribution is in the Mogollon Highlands. Phil McNally has demonstrated a really cool piece of information about the Mogollon Highlands. So we have many agaves here, some endemic, but this particular one, agave chrysantha, is a host to the endemic Bowers giant skipper, and their distribution, as you can see, overlaps. We also have some unique taxa that occur only in the Mogollon Highlands. Our own pinyon, Pinus edulis variety phallax, has been called Pinus phallax at other times, and has had other names as well. But it is definitely a unique pinyon biologically. It doesn't behave like other pinyons. It doesn't even really look in a lot of ways like other pinyons. So it's one of our unique species. And then we have other unique species that are endemic as well. If we look at these pinyons and junipers, we see kind of a cool part of this overlap analysis. I think it's a cool part. If we take all the pinyons and junipers from the southwest, and we do this elliptical analysis and overlay them, we see that 6 of the 8 pinyons overlap right in our Mogollon Highlands. And then if we add to that the woody shrubs, and I'm getting to why woody shrubs are important in just a minute, we see that out of the 20 species here, 17 of them overlap in the Mogollon Highlands. And so I could give you lots more examples, but I think you're getting the point. And this is an ongoing work. We're going to continue to look at these overlaps. Every day when I talk to someone, they send a new species. Bob just sent Dahlia. I was so excited about Dahlia. I'm going, you're right. It's one of our species. And so I think more and more, as people contribute their interest, we'll be able to look more at, we're looking at snakes. We're looking at lizards. We're looking at birds, particularly breeding. We're going to do breeding birds, right? Yeah. Getting assurance from Tom. But there are some birds, for example, whose northern distribution ends here. For example, the Gila woodpecker. I should have brought a bird slide for the Audubon Society. I'm sorry. Okay, so this area, you know, we often call it just one large ecotone. It certainly is an ecological transition area, an area of overlap, a unique area but no one has really had the opportunity to study this area very well. I just came from a workshop with the Forest Service in Phoenix today, where we were recognizing, these were all the biologists and foresters and fire people from the Prescott and the Tonto. And we were realizing that there are so many questions, we're generating questions that we don't really know about this area, that we know pretty well the answers up on the Mogollon Rim. So this is kind of always been sort of a black hole of research, and we're really happy at the Natural History Institute to be able to start filling in some of those gaps floristically and in terms of processes. So there are 3 projects that I'm involved in that I thought you might be interested in to talk about briefly tonight that involve fire in this system. So first I want to talk about just the fire history of these ponderosa pine woodlands that are in our area. Secondly, I want to talk about what's going on with some of the wildfires that we've had in the past years in the ponderosa pine. And finally, I want to take a brief look at the Dosey fire, which was a pinyon juniper fire. And I know we all know these fires, and so it's kind of neat that some data are starting to come out on these. So we're trying to stop neglecting this area and start paying attention. Okay. So one of the outcomes of having all these shrubs coming in from Mexico and other areas and converging here is that our ponderosa pine forests are entirely different from other ponderosa pine forests. They are very, very shrub rich. They're difficult to walk in. They present large conundrums to fire managers because we have all this understory. And we actually call them something different. We call them transitional ponderosa pine forests and not regular pine forests. So that's actually a forestry word for these systems. This is one we're very familiar with. Our ponderosa pine forests often are juxtaposed with interior chaparral. For example, this area in the Battle Flat zone that actually burnt up in the Gladiator fire. Our transitional forests tend to be not that old, maybe 100 years old, maybe a little bit older for the trees. They are uneven age, so we have small trees, we have large trees. We don't necessarily have stands all of one age. And we have an abundant array of understory shrubs, and that's the key to fire in this area. Scene you all know very well. So some of these shrubs, I just want to go through them because they're so cool. So we have 3 species of Arctostaphylos or manzanillas. One's very rare in our area, more northern. We have the right silk tassel, very important species. Oaks, oaks, oaks. There's so many of them. I'm just showing you a few, but you're all, I'm sure, familiar. It's funny that I didn't put a picture of the scrub oak, but we know that one really well, right? Turbinella. Tilia, trifoliata. In fact, Sam, I think that might be your picture of Tilia. Yeah, I think so, from the Dosey fire. And Rhus trilobata. And then there's a whole suite of really important shrubs that are in the Rosaceae for the most part, in the rose family. And they have actinorhizal or bacteria in their roots. And these bacteria fix nitrogen from the atmosphere and make it available to the plants. And so they're very important for biogeochemical cycling and really important, particularly after fire, and I'll come back to that. So they fix nitrogen. We have Persia, we have Ceanothus, Cercocarpus, mountain mahogany, and Apache plume, Falugia are some examples of those, and there are others. Okay, so the big question that we're grappling with in this project with the, it's a consortium of Prescott College, the Ecological Restoration Institute, and the Prescott Forest. And we are wrestling with the current conditions in the forest. We know that it doesn't look like this, right? And so we have historic photos from Charlotte Hall. There are many, many photos. We're going through those and trying to get a sense of what did this forest look like 100 years ago, or as far back as we can see with photos. We know, at least from these examples, that there were cases where there were very few shrubs in the understory and a much more herbaceous layer. We also have been able, through this study, to find numerous fire-scarred stumps, and you're probably really familiar with walking through the forest and seeing these triangular burns at the base of trees or at stumps that were often cut about this high because people use those kinds of saws. What are those called? There's another name for cross saws, though, with two people. Anyway, what is it called? Maybe it's a buck saw. Anyway, those kinds of saws that, you know, so they didn't get real low, and it's lucky for us because they left the fire scars. So we've been able to go and sample throughout the forest, both the Prescott forest and the Tonto. And both of these areas that have been studied are really, really shrub-rich types of habitats. This study started in 2017. However, Prescott College had the opportunity of sampling in the Schoolhouse Gulch area in 1995, 1996 with a colleague who's now passed, Paul Sneed. And Paul had the foresight to say to the Forest Service, you're going to start burning this area, you're going to start treating this area, and we don't even know what the fire history was. And so we got a small grant at that time, a challenge cost share with the Forest Service, and we went out and we just collected hundreds of fire scars from the Schoolhouse Gulch drainage and the Wolf Creek drainage and the Highland Pines areas before they started doing the treatments. We did a pilot. We were able to look at those sections a long time ago, but we were never able to finish them because that takes a lot of funding. And so luckily, the Ecological Restoration Institute at NAU became my collaborator with this. And now, in 2017, we were able to go out both here on the Prescott and the Tonto and grid out large areas with consistent sampling points throughout, for example, Schoolhouse Gulch and up, this one's in Ellison Creek on the Tonto, and collect all the fire scars near these. And I'm going to pass some of these fire scars around. Would that be? Yeah, I can do that. I'll pass the light ones around and because they're easier to pass around. But when these get, put that down. When these get sampled, they get sampled with a chainsaw, and you take a little slice like this out of them. Okay, it's a cookie. It's called a cookie. And you can see, this is one from Schoolhouse that we actually collected in 1995. So if you look at this closely, you can see an indentation where fires have scarred in the past. Can you see that even from where you are? And when you look at these, you'll see probably 22 or 23 such indentations on a piece like this, which means that about every other year, these trees experienced a surface fire that didn't kill them. It just burnt one side of the fire. I'm going to pass that around. I'm going to pass around the little two, and then afterwards I can show you all the larger ones where you can get a little more detail. It's kind of dark. They're marked for the dates. It's just so cool. And so what we did is we went out, made circular plots, counted all the species, got the samples. For example, here's a beautiful cross section. You section through that log. You get a piece that looks like this, and then you sand it, and you start seeing all these dates. So there are 3 fire dates. So far, we have one of the largest samples in the Southwest. We will, by the end of the study, have analyzed a bigger sample than any other samples. Here's some examples, so you could start getting fixed for this when you're in the forest. You'll see. Do you all see these? Yeah. I know that sometimes they're easy to walk past, but they are really, if you look at them, you'll see the lumps in there from all the different years. So we cut them. They're being processed, and you're seeing some of them, and the data should be available within the next year. And it takes a long time to do the sampling. But I can share with you some preliminary data from our pilot study in 1996 that came out in 2002. And we actually found that here on the Prescott, we had an average fire interval, the time between two fires, of roughly 2.1 years. And that means that a surface fire came through the area every other year, essentially. That is really, really fast. And what it suggests is that the shrubs probably weren't as prolific an element in the understory as they are today. They might have been here, they might have been trapped in little pockets in little refugia, but could they have been solid like they are now? We could never have a 2-year fire interval. And then, like so many areas of the Southwest, by about 1870, that all changed. And we stopped seeing these fires. And this is a classic pattern throughout the West. And it has to do with a lot of different things, but we're quite sure it has to do with our impact on the environment through grazing, bringing in sheep to the area, bringing in cattle that just removed the fine fuels so you could no longer have fire going through the area, or fire suppression later affected it, logging certainly affected it. So lots of our human impact has contributed to this hiatus of fire. So we see the Prescott as a place, and we'll get reinforcement for this, that had very, very frequent fire till about 1870, and then fuels started to build to the kind of situation we see now. And what we see now is also rising temperatures, drought. You've all seen maps like this. It's only going to get worse, these drought maps. You may have all been here in 2000 when we had the beetles. We thought we weren't going to have another ponderosa pine to ever see in our lives, right? And so many changes that have occurred. And the culmination of that and the change of fuels has been that our surface fires that we would have expected in these ponderosa pines from these kinds of data have now turned to crown fires. And so many of you, I'm sure, have probably even had to evacuate, right? We've had so many large crown fires in our area. The Yarnell fire was primarily in Chaparral. There was not any ponderosa pine there. We had the Dosey fire in Pinyon. And in ponderosa pine, the transitional ponderosa pine, we had the Gladiator fire in 2012, the Lane 2 fire in 2008. There was a fire in 2010. And then there's the fire, I guess I don't have a picture of it, the fire just last summer, the Goodwin fire, which actually reburnt. That's the one that reburnt the Battle Flat fire. So now we're having these larger, much larger crown fires. Very different characteristic of fire. So what I want to talk about then is what happens after those fires. If this is an area that evolved with a very rich biodiversity, that evolved with a surface fire regime, what happens when you then have a crown fire and expose a very different kind of terrain? If you go to ponderosa pine forests, well, either in town here or on the Mogollon Rim, the typical vision that we've always had of ponderosa pine is dog hair thickets coming in, lots and lots of ponderosa pine. Well, in fact, following our fires, the Indian fire, the Gladiator fire, and the Lane 2 fire, a student at Prescott College named James Holderer did a very thorough investigation of all of these fires and found that there was really no regeneration of ponderosa pine in the fires. And we have based our original look at these fires on the fact that this is happening all over the Southwest. People have been talking about the double whammy, the wildfires being of a different character and the drought, together making it so ponderosa pine just doesn't want to, just can't do it anymore. And that's a big concern to those of us who love ponderosa pine, but who also think that we should have resilient forests that are able to return to their previous pattern. So James asked, what does it take to get a ponderosa pine to germinate and establish after these fires? And what he found was that if he looked across these fires and compared them to unburned, that this is the ponderosa pine seedlings. There were no seedlings in the 2002, 2008, but there were in the 2012. And that almost the reverse of that is the shrubs, right? So you can just kind of, if you superimpose these, you could see them fitting. Where there are a lot of shrubs, there are not ponderosa pines. So what he found was that the reason that we had some regeneration in the Gladiator fire in 2012 was that 2013 was a very wet year, you might remember. It was abnormally wet for us, kind of exciting. And the ponderosa pines were able to come into there before the shrubs came in. So even though the older fires experienced the same precipitation, it was too late. That window of opportunity had been closed. So as long as you can get enough precipitation and seeds before you get the shrubs coming in, you might get regeneration of ponderosa pine. And this is playing out in a lot of different areas. So shrubs compete, in other words, negatively correlate with ponderosa pines. And here is that one burst of precipitation that we had. All the other fires, particularly the 2002, was followed by drought, and the 2008 was followed by drought. And the shrubs, they do pretty well in the drought. They can respond, they come on in, and then they can outcompete our seedlings. So the take-home message from that study is that we are looking at a kind of a type conversion from ponderosa pine forests into interior chaparral. And part of that is because we have both of those elements here in this grand overlap area that we have. They're here, they're native, and that transition is changing and shifting more to the chaparral. Okay, then I want to switch to my next example, my last example, and that is the pinyon juniper woodlands. And the pinyon juniper woodlands have a very different kind of fire history. Though I didn't bring any data today to show you this, we have found that pinyon juniper doesn't scar like ponderosa. In fact, when there's a fire with pinyon juniper, they die. They're very thin bark, and they just can't withstand it. Juniper can withstand a little more, but pinyons are out when there's fire. And so the fire history of pinyon juniper woodlands is very different from ponderosa. They experience growth for maybe 300-400 years, sometimes 500 and 600 years. The trees become very, very old, and then there's a crown fire, and they all burn up, and it all starts over again. So very different. No kind of surface fire like you see in ponderosa pine. So that said, we have some funny junipers here in this area, like the alligator juniper, which can resprout after fire. That's the only one that can, but our pinyons will die. The pinyon juniper zone is also juxtaposed with the interior chaparral here. So we have lots and lots of shrubs in that area as well. And we experienced only one pinyon juniper fire here in recent history, and that was the 2013 Dosey fire. The Dosey fire was what I would call a great fire. It was exactly within the historic range of variability. It didn't burn anybody's houses. It was just a really natural, wonderful fire. And I've been watching it since then to see what the patterns are, because there's so few here that we really haven't had an opportunity to see them. So with students over time, we have been monitoring the south end of the fire where there was chaparral down by the Spruce Mountain Trailhead, not Spruce Mountain, West Spruce Trailhead, where the fire started, and then the ecotonal area where it had pinyon and shrubs, and then finally on the north side of Granite Mountain where it was old-growth pinyon juniper. So it's kind of a neat study across the three. And if you're hikers, you probably often hike right through the middle on the Little Granite Trail. So just as you break into the fire, that's one of our study areas, which is the ecotone area. So we've been looking at it for every year or every other year since the fire. And we found some interesting things. I thought I'd just share a couple of trends with you. Now remember, this is a fire that is within the historic range of variability. The ponderosa fires are outside of the range of historic variability. So this is one where we would expect to see native processes. And we do. We see regeneration of shrubs. We see a fantastic array of forbs. Have you been up after it rains in that fire? It's just so beautiful, just wildfires, flowers all over, and lots of shrubs. One of the things about the pinyon juniper woodlands here is that they are very prolific in an unburned kind of situation. You see lots and lots of seedlings and saplings, and then it breaks out to very few trees in the 300 or 400 year range. In other places where I've studied pinyons, this would go way out to 600, 800. We just dated pinyons in Dinosaur National Park that are over 1,000 years old. Big pinyons. So our pinyons, as I said, they're different. They're different. And they're smaller, and they're shorter lived. And the fire cycle is a little faster than it is, I believe, in other areas where I've studied. But this is from Prescott, and you just see this classic drop in seedlings. So we expect a lot of pinyon seedlings. After the Dosey fire, we're not seeing yet any seedlings. And I'm not really concerned yet, like I am with the ponderosa pine, because sometimes it takes a long time. In places like Mesa Verde National Park, it takes 75 years for pinyons and junipers to start coming into the area. So we'll see. This could be okay. The resprouting chaparral is about a half of the unburned area, so it's come in pretty good. 3 years, it's about half the cover, which is neat. Herbaceous recruitment is very interesting. Another student, Brittany Zell, did her senior work looking at how many species, what was the diversity of species, and she found that species richness in the pinyon juniper zone, if you compared unburned to burned side by side, they were just about the same. But in the chaparral, you got a big boost in herbaceous species after fire. So that's where you really see the flush of beautiful forbs that maybe were living in the seed bank. Pretty cool, exciting stuff from Brittany. Okay, so earlier I mentioned that we had these shrubs here that fixed nitrogen. This is one of them, circle carpus, mountain mahogany, very, very common, with the wonderful little plume that we have here. And it's really important for biogeochemical cycling, particularly for bringing nitrogen into the landscape. So I got pretty concerned about this. If you walk on that trail, this is the trail right here, the Little Granite Trail, and you look at the burned and the unburned, you not only see a difference in the stature, that makes sense, but what we're seeing is a difference in the species. So that on this side, in the burned, it is almost entirely scrub oak. And on this side, the cover's 90% Cercocarpus or mountain mahogany. So there is definitely a shift. The mountain mahogany is losing this battle. The scrub oak is winning. It's not a nitrogen fixer. And so there seems to be a functional change in biogeochemistry that it's concerning to me. I don't know if it's natural or not. It's concerning, though. Here we see this more graphically. The unburned areas have both non-fixers and fixers. The burned areas have really, the non-fixers have taken over. So I did some soil analyses and thought, well, maybe that isn't so bad, but does it translate to different nutrients in the soil? And in fact, in side-by-side comparisons, there's definitely a drop in total nitrogen and in nitrate, two important measures of nitrogen in those burned areas. And usually after a burn, you see a spike in nitrogen. So this is a little bit concerning. It may be that ultimately those species come in, but they don't come in from seed very well. Most of our shrubs have lignotumors underneath the ground, big woody masses of photosynthetic material, and they sprout after fires. That's why they come in so quick and outcompete everything else. So it's kind of both a blessing and a curse to have those. Okay, in summary then, I hope I've made a case for the Mogollon Highlands being this unique biogeographic area that really deserves our attention in a lot of ways. We hope that you'll all get involved with our effort at the Natural History Institute to catalog all the plants here. We're building the herbarium. We want to have different initiatives that I'm sure Tom would love to speak to build what we know about this very wonderful, unique area. And one of the wonderful, unique things is this transitional ponderosa pine forest. So all of a sudden, there's a lot of attention. It's sort of like, oh, the transitional forest. Everyone wants to have workshops. Everyone wants to have projects. You know, foresters are getting really interested. It's kind of one of those things that all of a sudden the idea caught on. It's really exciting to me. And this transitional forest is now getting the attention it deserves. The other ponderosa pine forests have had a lot of attention up on the Ren, but ours is different. So we're finally getting there. And for the foresters, those shrubs are really, they're a curse. I mean, they don't know what to do with them, because every treatment that they do to try to reduce the fuels in our forests and be able to return fire to those forests also facilitates shrubs. And shrubs are ladder fuels that'll cause crown fires. So we spent the whole day in roundtable discussions just trying to figure out what are the questions, the research questions that we need to address just to figure out what to do with these shrubs, You don't want to kill them. They're part of our natural biodiversity. But certainly if you burn enough, you can keep them down. And you've probably seen this in Schoolhouse Gulch. On the upper end of Schoolhouse Gulch, if you come in from Senator Highway, they have burned and masticated and thinned and gone back in and burned more and maybe 7 different treatments in one area. And there the shrubs are way down. They're still there, but they're way down in biomass, and the diversity is pretty high. So it may take that kind of treatment to actually restore these forests to their natural kind of condition. And so both a blessing to us who love biodiversity and a curse to those who have to manage it. And finally, I just wanted to let you know about this collaborative study that's going on. Our field crews will be out again this summer. And this summer we'll be looking at treatment effectiveness. So the Forest Service has been doing a lot of treatments over time. And we're going to set out an experimental design looking at all those treatments and figuring out how well they've worked and really what are the goals of the treatments. So it's kind of exciting. The Forest Service would like to expand their treatments outside of the town limits. That's called the WUI, the area where the urban and wilderness interface, the WUI. And most of the treatments up to this point have been done there, but they're trying to now expand beyond the WUI. So that's kind of what we're talking about today. What are the best ways to do that? So just heads up that people will be out there. All right, well, that's all I have formally to talk about. I just want to acknowledge all the people who have contributed to this project. Dave Hanna's done a lot of all the GIS on our project, let's be honest. Tom and I are very involved, but Dave Hanna does all the work. James Holder, and then the Prescott College's Fire Ecology Group, some of which are here in the audience, collected a lot of the data on the fires previously, and the ERI field crews have also hired a lot of Prescott College students, so it's a really exciting opportunity for them, and then all the foresters that I've been working with on the Tonto and the Prescott. So there's a lot of people involved, and I'm just trying to kind of summarize their work for all of you. Okay, questions? Yeah.
I noticed that the ponderosa grows where it's cooler.
Mm-hmm.
And I don't know if it's cooler there because the ponderosa is there, or whether
Yeah.
ponderosa is there because it's cooler. Maybe it's some of both. But
Yeah.
does it ever happen that ponderosa comes in later under the oaks, or is that impossible?
Yeah, it can come in under the oaks, but let me address your cooler question. This is a very interesting thing. So for ponderosa pine to germinate, it needs bare mineral soil. It doesn't like nurse plants. Pinyon likes nurse plants, but ponderosa doesn't. And one of the things that they're finding on the Tonto is that if they thin the forest too much, so that they can get the kind of conditions where they think the ponderosa is going to come in, it only comes in where it's cool, i.e. where the shade is. So only if they stick to a 1/4 acre or smaller for their openings, and then have enough large trees to give shade and keep the soils cool, then they get regeneration. The other place you see it is in waterways, just right near the water. But typically ponderosa would have been much more prolific. But now I think soil temperatures are high, and I think you're right. They have to be in cooler, somewhat shaded areas. Mm-hmm.
Just the oak shade, totally shade them out, or does it allow them to break through?
They can break through sometimes, yeah. If they've established in the bare mineral soil, gotten to be about that big, then they can get through. Yeah. Yes?
Something that I'm wondering about is, it sounds to me like the fire service is the Forest Service is trying to figure out what to restore this to. And I'm wondering how they can figure out what they want to restore it to, especially considering climate change being so rapid and things at lower elevation are moving to higher elevation.
I wish you were at the workshop today. This is what we talked about all day. No, this is a serious question. What is the goal? And so, for example, we've been talking about these ponderosa pine forests maybe converting to interior chaparral. Is that bad? Is that just what is happening? Is that an okay goal? There's no erosion. There's still going to be a lot of bird species in there. There's, some attributes that are good. But most of us would rather see a ponderosa pine forest coming back, right? It's a values thing. We talked a lot today. This is a very un-Forest Service-like. Are any of you in the Forest Service? It was this whole thing where we were talking about values and caring and what do we want? Because the answer to Adam's question doesn't exist. It's like, how do you know? Well, we feel like we should have ponderosa pine forests. So one way that we try to get at this question is by developing reference conditions. So we try to create a goal that seems reasonable so that you can restore back to that goal. The reference condition that's been classically used in ponderosa pine across the Southwest is that period right before 1870 or 1880 when the Anglo population moved in, brought sheep, brought logging, brought railroads, made all those kinds of changes on the landscape. So the idea was it was good before then and it's bad afterwards because all the tiny trees have come in. Those are values, those are value judgments. We may not even be able to use that reference condition anymore because of climate change. Things are changing. Maybe it would be a really good thing if we had interior chaparral in big patches within the existing forest. It may be that that's what the reference condition is going to have to be. So this is what kind of thing we're struggling with all day, and people are saying, but, it's true. I mean, there's no perfect answer to that reference condition question, and people are getting faced with that. Yeah.
Hold on real quick. Let me get the mic on.
Is there anything to be learned from the prescribed burns that have been going on in southern pine forests since the 60s?
In southern pine,
Yeah.
there's much to be learned from those, but it is not directly applicable to our situation. That's another surface fire regime where fires are very frequent on short intervals, but the understory is so different. We can't even really extrapolate from the Mogollon Rim to the Mogollon Highlands, honestly, because everything is so different. But yeah, there's so much to be learned from that. At first I thought you were going to say, is there much to be learned from the prescribed burning and the treatments that have been going on here in the Prescott? And that's what we're setting out this year, is a study of trying to look at our own treatments and say, what can we really learn about the prescribed burning? So for example, what I've learned so far is that if you only go in and burn once, thin and burn once, then you increase the shrubs. And the shrubs, ladder fuels are just happy and you'll have a wildfire. If you go in multiple times with multiple kinds of treatments, my pilot data suggests that will bring down the shrubs and keep them low and keep them from being ladder. Do you know what I mean when I say ladder fuels? They just bring it up to the top of the crown. And so that's been part of the approach. You see a lot of hand thinning on the forest. Lately, if you've gone out Thumb Butte and gone down that trail, what's the name of that trail with the little fireplace out there? Do you know? Fireplace Spring, right down there. They've done a whole lot of hand thinning there to reduce those ladder fuels, and then they're going to go in and do a burn. And I know, and when it's happening, it's hard to look at. You're going, ooh, look, they cut all those. But give it a year or two after that burning, and it's going to be a much safer, more natural kind of place. You just can't do that everywhere, though. Yeah.
How often do they have to do the prescribed burns to do? How often do they have to do the prescribed burns to do what you were saying? Like 6 or 7 times.
Yeah, there's a fellow who on the force here who's been doing these prescribed burns for about 20 years, Bucky. And someone asked Bucky that question today. And he feels like with the mastication, if they go and chew up all this stuff first, and then burn again within about a 5-year window, it's looking good. We're going to go in and really test this, so I'll have a better answer to your question next time around. But I'm thinking as long as they re-burn within about a 3 to 5 year window is probably going to be the right time frame. Sam?
Does the heat and intensity of the ground fires affect the viability of ponderous pine seeds to regerminate?
Yeah. So the seeds aren't in a seed bank, right? They don't build up like some other kinds of systems. Instead, you have to have seed trees nearby enough, and those seeds, and we do have seed trees left all through the forest, and they blow. So those seeds will get to the bare mineral soil and germinate, unless it's too hot, as this gentleman was talking about. Heat is one thing, and if there's not enough precipitation. So definitely the characteristics of the soil have to be right, and that could be part of it. The other characteristic of the soil that we haven't talked about at all is the biota in the soil, the bacteria and the fungi. And they're in a place that doesn't normally have wildfires. If you then get a very, very hot wildfire, you kill a lot of that biota that is very likely part of the germination process. So mycorrhizae, bacteria are probably really important. Roger.
We got a ponderosa in the front yard with a whole lot of pine cones. So those pine cones, did you say they blow around?
The seed,
seeds?
yeah, the seed blows.
I haven't actually seen the seeds.
You haven't seen the seeds?
No.
You gotta stay up all night. You should, trying to think of exactly when they disperse.
Do they come out of the cones before the cones fall?
Yeah,
Okay.
yes.
Yeah.
Mhm. And they are, lots of birds very much depend on those seeds before they fall. And particularly with pinyon. Pinyon is wingless. And so the seed just sits in that scale. And pinyon jays, Clark's nutcracker, lots of corvids are dependent on those seeds. In fact, pinyon jays, the gonadal development, the testes development, depends on the bird seeing those seeds. And once it sees the green cones and the seeds, then it knows, good time to reproduce, because we have enough food for the babies, right? So the cones open. There's quite a coevolution of the two. The cones open, the birds pick the seeds out, they flock, as you know, you're all birders, right? In these big, squawky flocks, they come in and they take all the seed, and then they plant it, right? Because they're doing it for the babies, right? But they're really doing it for the pinions. So they plant it in these beautiful germinable sites, and they only recover, the estimates are about 1/3 of the seed that they plant. So this is a really cool thing for the pinions. In fact, pinions have got to be in sites like that. They're not like ponderosa. Ponderosa can blow anywhere. As long as the soil's right, it can germinate. But pinions aren't like that. They need a little home, shade. Yeah. There's a great book you might want to read called Made for Each Other, about pinyon jays and pinyon reproduction. Scrub jays too eat them though, right? Anything else? Yeah, sure do.
Yeah, what sort of window are you looking at for precipitation in regards to ponderosa regeneration?
I think that precip has to happen within 2 years. So the 2012 fire, the only one that we got decent regeneration, was in the late part of the year. I think it was in August. And the precip event was in 2013 monsoon. So that was within a year. And we aged the seedlings to see if they tied into that, and they did. So that was a 1-year window before the shrubs came in, but maybe 2 years might be all right. Guess it depends on how much shrubs were in there to begin with to resprout. But the shrubs will sprout. They're not really precip dependent for a while at least. Yeah.
Do you know what the rationale behind these piles is, where they leave the pile and then burn it later?
No. I'm not like a fan of all the things that happen. It's the hand thinning, right? And instead of actually taking that fuel out of the forest, which would be very, very costly, they burn it in place. I would prefer that it was scattered and burned, because then the nutrients would go into the soil in a dispersed way. But that would then be much more dangerous for the firefighting personnel and for everybody. So they take it out. In Colorado, where I do a lot of work, they actually truck it out into big piles that are as big as this room and then have one giant bonfire. Yeah. We're trying to get them to give the wood away. It's juniper, give it to people who need firewood. But the Park Service they can't sell it. It's some kind of problem. So until they figure out how to do that, they burn it in huge piles.
See it from the satellite.
Yeah. Oh, it's that, it is that big.
Another question about specifics. You mentioned 5 different kinds of junipers. Is that what it was?
Yeah, 5.
I want
let's
to
see.
ask you what the shaggy bark juniper is.
Well, that's Utah juniper. Well, shaggy bark is a common name for both the Utah juniper, Juniperus osteosperma, and the Juniperus monosperma. So the problem with using shaggy bark. So common names, as my students know, are terrible, right?
We got some juniper. We just made a spear out of juniper.
Yeah, I know.
And I would like to know what kind it is. It's shaggy bark, but it was from over on the other, just on the other side of I-17, you know.
Could be either monosperma or osteosperma. If you don't, do you have a picture of it?
Yeah, but it looks like a spear.
Oh, yeah,
She
yeah.
knows, okay.
You know which one it is? Which one?
I forgot
I
to
think it's
ask
the
her.
Utah.
Yeah,
The shape of the tree.
There's definitely more of the Utahs in this area. Any other comments? All right. Well, thank you for your attention. I know it's late.
Thank you.